Okay, hey everyone. This is probably not a bad topic to be doing from the comfort of your own home, because there's a fair bit of revision from methods, and it gives you good practice for all of your basic algebra, factorizing, using the quad formula, etc. So what is this topic, you ask? Real and complex numbers. Okay, and the complex part of it, that's coming in where we have imaginary numbers. Okay, so the big deal is that we have I is the square root of -1. So up until this point, if you tried to take the square root of a negative number, we would go, no, that can't happen. But now what we can say is, well, if I have the square root of -4, this is actually now going to be -1 times 4, and we can split that up. Just give myself a little bit more room here. We can split that up using our indice rules, or sorry, our surd rules, right? Remember, we've got root AB. We can split that to be root A times root B. So we can do that it's -1 minus root 1, times root 4. Now we know that the square root of 4 is 2, and the square root of -1, bang, is I. So we get plus or minus, because that comes from the square root of 4, can be plus or minus 2. So plus or minus 2i. It's that simple. If I had the square root of -7, then I can just write that again. That's -1 times root 7, and you don't do that line anymore, right? You just go, it's I root 7. Okay, and of course, yeah, you can stick the plus or minus in there if you want to. Now, before we get started on some of this other stuff, I need you to grab your graphics calculators. So pause the video if you need to, although I'd like to think that you had them right there ready to go. So if we turn our calculators on and we go into the normal run mode, if I type in here, let's take the square root of -4, it tells us error, which is what our old scientific calculators used to say. Some of you might have actually got the 2i as an answer. That would be because you have changed your settings, which is fantastic. So we go to Shift, Menu. I'm going to scroll down until we see, oh, there it is, went past it, complex mode. Now you can see mine's on real. So if I press F2, it becomes A plus BI. Press exit. And now when I press enter, you can see that I've got 2i. We've also got I on our calculator. So we can see down here above the 0, if I press Shift I squared, we get -1. Some of the calculations that we're going to do a little bit later, they used to be really good calculations for teachers to get you to show us by hand that you can understand the processes, and now your calculator does it beautifully for you. However, all I have to do is say show algebraically, and bang. So we're going to be able to use our calculators to check, but we hopefully can also do it by hand. So a couple of examples they're going to ask you. Make sure that you read the question carefully. We could have this question here. Now this one says solve for the quadratic equations. These are your examples, just popping them here. So again, we can just say, well, that's pretty easy. To get rid of a squared, we simply square root. So we just did a question like that, the square root of -4. Therefore, x can be plus or minus 2i. Please be careful though, and make sure that you read the questions, because if it said solve the quadratic, you can do any way you want. If it said write as a product of linear factors and hence solve, well, then you have to factorize, right? Now, again, up until this point, something like this, we wouldn't have been able to factorize, not possible. What I'd like you to think about or consider is if it was x squared take 4, all of us straight away goes, yes, it's our favorite difference of 2 squares. So that would be x take 2, x plus 2 gives me 0, and therefore we've got x is plus or minus 2. Well, we're using that same theory to factorize x squared plus 4, because what we end up having now is instead of plus 2, we have 2i and then take 2i. So we're still using this process of difference of two squares because it allows us to get rid of the middle term. And let's just check with the expansion here. So x times x, I get my x squared, which is great. X times minus 2i, I get minus 2ix, but then I get the plus 2ix. So your middle terms disappear. However, am I going to get the plus 4? So a positive times a negative. So plus 2 times, I'll just write it down for you. So 2i times negative 2i. So a positive 2 times negative 2 gives me negative 4. But I times I gives me I squared. And of course, I squared is negative 1. And so, bang, that's how we get our plus 4. So that does work. So keep in mind, we had our rule of a squared minus b squared equals 0. Difference of two squares, we factorize that like so. Well, now when we've got a squared plus b squared, that's going to be a take bi, a plus bi. Okie dokes. Okay, when we have this with we don't know what the square root of that is. Recall that would just be root 11. So plus I root 11 times x take I root 11. Now, again, make sure that you're answering the question. This one said just write it as a product of linear factors, so you're done. If it had said solve, then it would be equal 0, and you must make sure that you finish off plus or minus I root 11. Hopefully you're finding that pretty simple. When we have something like this, actually I'll come back to that one. We can, or actually no, we'll go back. When you have something like this, we take a few seconds out of our busy lives and we do the old, can we factorize this? So we're looking for two numbers that times together gives me 2, but adds up to be 1. Now the only factors of 2 are 1 and 2. Clearly, because that's a positive, we cannot get a 1z from that. So you can't factorize it. So then when you can't factorize something, we bring in the big guns of the quad formula. Hopefully most of you remember your quad formula. Minus b plus or minus b squared for ac, and finish it off over 2a. So we chug along, and look, let's just save you and myself a bit of reading and writing here. We whack it into the quad formula, and big difference is that now we get the minus 7 underneath the square root. So we just write that as I root 7. Okay, minus 1 plus or minus root 7. I root 7 over 2. Now back to our calculators. Will this work? So when we go into the equation, okay, polynomial, degree 2. So we had 1, 1, and 2. We press solve, and you can see that we do indeed get our imaginary answers there. But all I have to do is say, can you please use algebra to show me, and then we're done. Just before I go, remember that whenever you're factorizing something, always look for a common factor. Do you remember what to do in a case like this? We don't like this divide by x, so you need to multiply through by x, then get everything on one side and away you go. Be careful with these. Remember when you're doing the a squared minus b squared, you take b, a plus b, what is the connection here? Oops, arrow was too big. Yeah, there we go. To the a, you have to square root. Okay, so here, what is the square root of 4x squared? That's going to be 2x. Take 3 times 2x plus 3. So please try not to skip any of these, because as you can see, they're sort of paired off. A is paired off with B, C is with D, and so on, because the only difference between them is that one's a minus and one's a plus. Okay, so the ones with the plus, that's going to include the i's on it. I know these are red, but I have faith that you can do it. Okay, so common factors, make sure we go common factors, and then see if you can keep going. So a great one that I like. Okay, if this is a typical question, if we have this, and I'm asking you to fully factorize that, I mean, okay, we'll fully factorize and solve as well. So there we go. How can I factorize this? Well, we can start, because the square root of x to the 4 is x squared, because this we recognize again is difference of two squares. So we get x squared take 9 and x squared plus 9. And we're quite happy here because again I can go difference of two squares again. So this becomes x take 3, x plus 3, and then x squared plus 9. Well, remember it's the plus there, so now it's going to be x take 3i, x plus 3i. Nice? I think you like it. Don't forget, finish off plus or minus 3, plus or minus 3i. And last but not least, something like this. We've checked there's no common factor there. And you think, well, what's going on? Because we've got the x to the 4. But if I had asked you, well, if instead of being x to the 4, if that was x squared minus x take 20, how would you go about factorizing that? Whole sum and product, bizzo. So with the 20 here, what are the two numbers that times together give me 20 but add up to be minus 1? So it's 4 and 5 that have the difference of 1, and I hope you would be able to easily just say, well, that must be x take 5, x plus 4. Okay? How does that apply here? Well, we just do the same thing, except instead of x take 5, it would be x squared take 5 and x squared plus 4. Right, because x squared times x squared gives me the x to the 4, x squared times 4 is 4x squared, minus 5x squared is the minus 1, and so on and so forth. Okay, so that's great. But have you fully factorized? Probably going to say pop it into linear factors, which means no x squareds here. So we're going to keep on going. This is difference of two squares again. That keeps popping up. So x squared minus root 5. Oops, and I got carried away there. Not x squared, it's just x take root 5, x plus root 5, and then our factor here of x squared plus 4. Remember, that's where we've got our i's again. So x plus 2i, x take 2i equals 0. So x can equal plus or minus 5, or x could equal plus or minus 2i. And yes, you can check that in your calculator, but you would just have to go now to degree 4. We've got 1, 0 x cubes minus 1x squared, 0 x's, and minus 20. Yeah, so let's look at it. We've got root 5, negative root 5. Wow. Wowza. So give this a whirl. If you get stuck on one, just flick me a message and I can help you with that. Remember, you also have the answers. I was going to do another video, but while we're here, the next little exercise that I would ask you to do is we're just playing around with imaginary numbers. I'm not going to insult your intelligence. I think you've got this under control, where if I've got Z and W, if you add them together, you just add the real parts. 3 plus 4, 7. 2i, take 1i is I. Similarly, you can see the subtraction. The thing that I want to draw your attention to is when you are dividing. Okay, what's going on here? We have to multiply by the conjugate. So be careful when you multiply by the conjugate. Downstairs, remember it's difference of 2 squares, so you don't have to have the middle term, that disappears. And as you can see, we just expand these brackets at the top the same way we would any one. So 3 times 4 is 12. That's how we get that. 3 times I is 3i. 2i times 4 is 8i. Now, 2i times I. Just a little bit of a tip here. When I do that and I'm doing I squares, instead of writing plus all the time, I write minus. I say, I've got the 2 there. I know there's a plus there. However, now I've got I squared, and I squared is minus 1, so minus times a positive gives me a minus. Right? Remember, if it happened to be a positive, you can always change a minus to a plus, but please don't do the, oh yeah, that's meant to be a minus. Don't do that. Okay? So you can gather your like terms. 3i plus another 8i is 11i. 12 take 2, that's how they got the 10 there. So stuff like this I would ask you to show me algebraically, because guess what? Your calculator, this is where it starts earning its cash, its value. If I say 3 plus 2, now to access my I use the shift button. 4 take I, press enter, wowzer, same answer. All right, so I'm going to ask you to just, we're not going to do them all, we're going to do 3, the last row, question 4, question 5, and question 6, and just 7C. So again, if you get stuck, please give me an email, let me know, or ask on Teams either today or tomorrow's lesson. Okay, cheers.